Hi all, welcome to Sahara IAS. Today in this class we will be seeing the introduction, these different laws that are relating to power, that is called as laws of exponents, and also the introduction for Surds. First let us try to understand what is the function that is called as power. Suppose if I say 2 is a constant which is to be multiplied for 3 times. 2 is multiplied for 3 times. This can be taken as 2 to the power of 3, which means the base here in this 2 is called as a base and 3 is called as the power. So what is the base here? Which number we are multiplying repeatedly is called as base, and how many times we are multiplying that number is called as the power. For example, suppose if I say 3 to the power of 4. 3 is a base, so I am multiplying 3 for how many times? I will be multiplying 3 for 4 times. So it is 3 into 3 into 3 into 3. This is what the power meaning is. Now, suppose if I take some random number a and raise it to the power of n, it means you are multiplying a for n times. This is what the meaning of power is, power function. Then a to the power of n, here a is called as base and n is called as power. And this will give a, if I take a large base and a large power, this will lead to a very huge number which cannot be expressed in terms of a simple number. So what we do, we will express this in terms of exponent. This is called as exponent. Now, there are certain laws which we have to follow while solving the exponent functions. Suppose if I say, let me write the heading, that is laws of exponents. First thing, any number if I take and raise it to the power of 1, this is nothing but the number itself. For example, 2 to the power of 1 is simply 2. Any number 123 to the power of 1 is just 123. Any number, if you raise it to the power of 1, you will get the number itself. Second point, if you consider any number a and raise it to the power of 0, then you will always get the answer as 1. For example, 2 to the power of 0 is 1. 123 to the power of 0 is also 1. So if you consider any number 3, 4, 5, 6, 7 to the power of 0 is also 1. Any larger number or any number in that case to raise to the power of 0 is equal to 1. This is applicable even for a fraction. If I consider 7 by 3 whole to the power of 0, this is also equal to 1. Third point, if I consider 1 as the base and raise it to the power of any number, then it will always give me 1 as the answer. For example, if I consider a to the power of 3, it means I am multiplying 1 3 times. But as we know, we multiply 1 for any number of terms, any number of times, the resultant is always 1, so it will be equal to 1. Similarly, a to the power of n, if you multiply a any number of times, even if I multiply this for infinite times, the final answer is still 1. So we can call it as a to the power of n is always equal to 1. And this n need not be a whole number, it can be a fraction as well. For example, a to the power of 3 by 4 is also equal to 1. 1 to the power of 3 by 4 is also equal to 1. So these are the first 3 rules we should be knowing. Coming to the second one. Fourth rule, suppose if I consider a to the power of n, this can be written as 1 by a to the power of n minus n. Similarly, a to the power of minus n can be written as 1 by a to the power of n. So if you shift the number which is having a power from numerator to denominator or from denominator to numerator, you need to change this sign. For example, suppose if I have 2 to the power of minus 3 into 3 to the power of 4, this can be written as 3 to the power of 4 divided by 2 to the power of plus 3. I am changing the sign of 2 to the power of minus 3 to 2 to the power of plus 3 because I am sending 2 to the power of minus 3 from the numerator to the denominator. This is nothing but divided by 1. So now I have only 1 in the denominator and I am sending this term to the denominator by changing the sign of the power. And suppose if I want to send 3 to the power of 4 to the denominator, 2 to the power of minus 3 into 3 to the power of 4 can also be written as 2 to the power of minus 3 divided by 3 to the power of minus 4. Now I am sending 3 to the power of 4 from the numerator to the denominator. So what I did? I changed the sign of 3 to the power of 4 as 3 to the power of minus 4. That is, I am changing the sign of the power. Suppose if the condition is like this, 2 to the power of 3 divided by 4 to the power of minus 5. Now, suppose if I want to send this denominator term to the numerator, I need to change the sign, so it will become 2 to the power of 3 into 4 to the power of plus 5 instead of minus 5. So this is how, if we send one term from the numerator to the denominator, it will become minus. If the power is minus, it will become plus. If the power is plus, it will become minus. Coming to the fifth point, suppose if I have same base a and a, but I am having power m here and I am having power n here, and I need to multiply these two terms. So the condition here is the base are same but the powers are different, then you should just add the power, that is a to the power of m plus n. The reason behind this is, if I consider 2 to the power of 3 into 2 to the power of 4. Now 2 to the power of 3 I can expand this as 2 into 2 into 2, and 2 to the power of 4 I can expand this as 2 into 2 into 2 into 2. Now if I multiply these two terms, it is simply multiplying 2 for 7 times, so it will be 2 to the power of 7, which is nothing but the addition of these powers. So we can write 2 to the power of 3 into 2 to the power of 4 can be written as 2 to the power of 3 plus 4 directly. Next point. If we consider a to the power of m divided by a to the power of n, this can also be written as a to the power of m divided by a to the power of n, both mean the same, and this will be equal to a to the power of m minus n. For example, if I consider 2 to the power of 7 divided by 2 to the power of 3. 2 to the power of 7, I can simply write this as 2 into 2 into 2 multiplied for how many times? We are multiplying it for 7 times. Divide it by 2 to the power of 3 simply means we are multiplying 2 for 3 times. Now if I cancel these 3 2's and these 3 2's, I am left with 4 2's, that is 2 into 2 into 2 into 2. And I am multiplying 2 for 4 times, and in the exponential format it can be written as 2 to the power of 4. So this 2 to the power of 4, if we observe, it is simply the subtraction of 3 from 7. So we can say 2 to the power of 7 divided by 2 to the power of 3 is directly 2 to the power of 7 minus 3, which is equal to 2 to the power of 4. So these are again the important laws of exponents which we will be using to solve the questions. Hope till here it is clear to everyone. Now we saw that what happens in the multiplication and division when the bases are same but the powers are different. Now I will reverse this. I will give you the condition wherein the bases are different but the powers are same. If you are multiplying a to the power of m into b to the power of m, here the bases are different but the powers are same, then you can simply merge this as a into b whole to the power of m. And in the division case, you can write this as a to the power of m divided by b to the power of m can be written as a divided by b whole to the power of m, or it can also be written as a by b whole to the power of m. Both means the same. So you can merge in the case of bases are different but the powers are same. Then suppose if the condition is given like this, a to the power of m divided by a to the power of let's say n. Now what can be written? This is nothing but the initial law. Is it same as this one? A to the power of m minus n. So you can directly write it as a to the power of m divided by n. But we already know that when we shift from denominator to numerator and numerator to denominator, we can simply change this sign. So this can also be written as, if I take a to the power of n to the numerator, it will be a to the power of minus n, and if I take a to the power of m to the denominator, it will be a to the power of minus m. So if I take minus common, then it will be a to the power of n divided by a to the power of m whole to the power of minus 1. I can even write like this. Hope everyone are following this. The second point, this can be taken, any number can be taken from numerator to denominator and denominator to numerator just by changing the sign of the power. For example, a to the power of m divided by a to the power of n, this can be taken as a to the power of m into, as I am taking a to the power of n to the numerator, I am changing the sign of n, so it will become a to the power of m into a to the power of minus n. Now, as the powers or bases are same, you can get it again, you will get back the same rule, that is m minus n. This is actually m plus of minus n. So m plus of minus n will be a to the power of m minus n. And what happens if I take a to the power of m to the denominator? A to the power of m divided by a to the power of n. If I want to take a to the power of m to the denominator, then it will become 1 divided by a to the power of m into a to the power of minus m. Now this is nothing but 1 by a to the power of n minus m. So if we observe this here, a to the power of m by a to the power of n can be written as a to the power of m minus n, and same thing can be written as 1 divided by a to the power of n minus m. So this gives to the next result, that is a to the power of x minus y can be written as 1 by a to the power of y minus x. Coming to the next rule, if we consider any number nth root of any number a, we can write this as a to the power of 1 by n. For example, if I consider 7th root of 2, this can be written as 2 to the power of 1 divided by 7, and this 1 divided by 7 is entire part is in the power. Then if I have anything for a to the power of nth root of a to the power of m, this can be written as a to the power of m whole to the power of 1 by n. Now we have one more law of exponent, that is a to the power of m whole to the power of n is equal to a to the power of m into n. Did we cover this? Okay, we have not covered this. So it is a to the power of m whole to the power of n is equal to a to the power of m into n. If I apply this formula here, I will get a to the power of m into 1 by n, which is nothing but a to the power of m divided by n. So these are some of the rules. Then we can go to the next rule. The next rule is like this. If I have a to the power of m is equal to p to the power of m. Here what is happening? The powers are same, but the base are different. Then I can directly equate the base. That is a is equal to b. Similarly, if I have a to the power of m is equal to a to the power of n. Now it is the reverse. Here what is happening? The base are same, but the powers are different. Here I can equate the powers. So when the bases are same, we can equate the powers, and when the powers are same, we can equate the base. For example, suppose if I say 2 to the power of x is equal to 2 to the power of y, I can equate x is equal to y because the bases are same. In the same way, 2 to the power of, let's say, 3 is equal to x to the power of 3. Now here the powers are same, so I can equate 2 and x, and I can say x is equal to 2. So these are some of the rules relating to law of exponents, and we will be using this in solving the problems in the next class. Thank you.